A sequence is a real valued function whose domain is the set of natural numbers. A sequence is a real valued function whose domain is the set of natural numbers. For example, consider the function f of x is equal to x square. If you take x is equal to 1, then f of 1 is equal to 1 square, which is equal to 1. If you take x is equal to 2, f of 2 is equal to 2 square, which is equal to 4. Then x is equal to 3. F of 3 is equal to 3 square is equal to 9. Thus, 1, 4, 9, 16, 25 is a sequence. Let us consider another example. Let f of x is equal to 2x minus 1. Let x is equal to 1. F of 1 will be 2 into 1 minus 1, that is 1. For x is equal to 2, f of 2 is equal to 2 to the 4 minus 1, 3. For x is equal to 3, f of 3 is equal to 5. Thus 1, 3, 5, 7, 9 is a sequence. Crudely, we can say that if the numbers are written in a definite pattern, then it is called a sequence. Then come to series. Sum of the terms of a sequence is called a series. Sum of the terms of a sequence is called series. Term specific sequences are called progression. Different types of progressions. The first one is called arithmetic progression. Arithmetic progression or AP, geometric progression, GP, third is a harmonic progression, HP, and the fourth one is arithmetico geometric progression, AGP. Okay, first of all, we'll discuss about arithmetic progression or AP. A sequence is called an AP if the difference between a term and its preceding term the difference between a term and its preceding term remains same throughout the sequence. A sequence is called an AP if the difference between a term and its preceding term remains same throughout the sequence. Okay. For example, A1, A2, A3, A4 up to AN is an AP if A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to AN minus 1. Take a particular example. 2, 6, 10, 14, 18 is an AP because 6 minus 2 is equal to 4, 10 minus 6 is equal to 4, 14 minus 10 is equal to 4, 18 minus 14 is equal to 4. The sequence maintains a constant difference, hence it is an AP. I have done a question. If the nth term of a sequence is a linear expression, if the nth term of a sequence is a linear expression in n, then show that the sequence is an AP. If the nth term of a sequence is a linear expression in n, then show that the sequence is an AP. Let Tn be the nth term. Tn is equal to linear expression in n, an plus b. If Tn is equal to n plus b, then what will be Tn minus 1? Tn minus 1 is equal to a into n minus 1 plus b. This is equal to an plus b minus of a. Then what is the difference between the nth term and n minus 1 term? Tn minus 1 equals to n plus b minus an plus b minus a, which equal to a. If we take n is equal to 2, so thus Tn minus Tn minus 1 is independent of a. So if you take n is equal to 2, T2 minus T1 is equal to a. If you take n is equal to 3, then T3 minus T2 is equal to a. If you take n is equal to 4, then T4 minus T3 is equal to a. The sequence maintains a constant difference, hence it is an AP. Is it clear to you? Write in the chat box whether it is clear to you. Pratisruti, explain again, okay? The theorem says that if the nth term of a sequence is a linear expression, then so that it is the sequence is an AP, right? Let Tn is equal to An plus B. You know, linear expression in Ax is Ax plus B. Quadratic expression in Ax is Ax square plus Bx plus C. So linear expression in N will be written as An plus B, where A and B are arbitrary constants. To prove that a sequence is an AP, we have to show that difference between a term and its preceding term always remains same. Okay. Nth term of the sequence is an plus b, and its preceding term at n minus 1 will be a times n minus 1 plus b, which is equal to an plus b minus a. Then tn minus 1, an plus b minus an plus b minus a, an plus b minus an plus b cancels, minus of minus a is a. So Tn minus 1 is a, which is independent of n. So if you take n is equal to 2, so T2 minus T2 minus 1, T1. T2 minus T1 is equal to a. For n is equal to 3, T3 minus T2 is equal to a. For n is equal to 4, T4 minus T3 is equal to a. Okay. So difference between a term and its preceding term remains same. Now you can say that the sequence is an AP. Pratisruti, is it clear to you? Write in the chat box. Okay. Then write down the next question. If the sum of n terms if the sum of Trupti Higher Secondary Basudevpur, is it clearly visible to you? If the sum of n terms of a sequence, okay. If the sum of n terms of a sequence is a quadratic expression, if the sum of n terms of a sequence is a quadratic expression in n, then show that the sequence is an AP. If the sum of n terms of a sequence is a quadratic expression in n, then show that the sequence is an FP. Generally, the sum. Let the sequence be A1, A2, A3 up to AN. The nth term of the sequence is denoted by Tn. Tn is equal to n, and sum to n terms is denoted by Sn. Sn is equal to A1 plus A2 plus A3 plus up to An minus 1 plus An. Sum of n terms is given by A1 plus A2 plus A3 up to An minus 1 plus An. And sum to n minus 1 terms, sum of n minus 1 terms will be A1 plus A2 plus A3 plus up to An minus 1. Right? Then what will be the difference of sum of n terms and sum of n minus 1 terms? Sn minus Sn minus 1 is equal to, so if you subtract the second equation from the first one, then only n will be left over, which is equal to an. Sn, n is your nth term. So note it down, Sn minus Sn minus 1 is equal to Tn. Note it down. It is given that the sum of n terms of a sequence is a quadratic expression in n. Sn is equal to an square plus bn plus c, where a, b, c are arbitrary constants. If Sn is equal to n square plus bn plus c, then what will be Sn minus 1? A into n minus 1 square plus b into n minus 1 plus sub c. So Tn is equal to Sn minus Sn minus 1, which is equal to an square plus bn plus c minus of a into n minus 1 square plus b into n minus 1 plus c. This is equal to an square minus a into n minus 1 square plus bn minus b into n minus 1 plus c minus c. C minus c cancels. Now you can take a as common from the first two terms. It will be a times n square minus n minus 1 square. From the next two terms, we can take b as common. B into n minus 1. C minus c cancels. This is equal to a times a square minus b square is a plus b into a minus b. That is a plus b, n plus n minus 1 into n minus n plus 1 plus b into n minus n plus 1. This is equal to a times 2n minus 1 plus up b. This is equal to 2an minus a plus b, which is equal to 2an plus b minus a. So Tn is a linear, this expression is a linear expression in n. Okay. The previous theorem says that if the nth term of a sequence is a linear expression in n, then the sequence is an AP. Here we proved that the sequence whose sum of n terms is a quadratic expression, then its n term is a linear expression in n. Hence, this implies the sequence the sequence is an AP. Okay? Is it clear to you? Write in the chat box whether it is clear. Okay. So A1, A2, A3, A4 up to AN is called an AP if A2 minus A1 is equal to A3 minus A2 equals to A4 minus A3 equals AN minus 1. Okay, the difference A2 minus A1, A4 minus A3 minus A2, A4 minus A3, the difference is called common difference. Okay, then come to general form of an AP. If A be the first term, and D be the common difference, if A be the first term and D be the common difference, then the sequence is given by, then the AP is A, Next term will be a plus d, a plus 2d, a plus 3d, up to a plus n minus 1 into d. Thus, the nth term of an AP, whose first term is a and common difference is d, is given by Tn is equal to a plus n minus 1 into d. Where a is the first term and d is the common difference. If the first term of an AP is given and the common difference is given, then we can calculate any of its term of the sequence. Okay. So write down a question. Find the 20th term of the sequence find the 20th term of the sequence 2, 5, 8, 11. Okay, this is the question. Come to the solution. Here the first term of the sequence is 2. A is equal to 2. Then we have to find the common difference D. Common difference D is equal to second term minus first term, or third term minus second term, or fourth term minus third term. So second term minus first term, that is 5 minus 2. 5 minus 2 is equal to 3. A is equal to 2 and D is equal to 3. So nth term Tn. Tn is equal to A plus n minus 1 times D. Tn is equal to A plus n minus 1 times D. So T20 is equal to A plus 20 minus 1 into D. Okay. What is A? A is equal to 2 plus 20 minus 1 is 19 into D is equal to 3. So 2 plus 19 3 is 57. 57 plus 2 is 59. Yes, Pratishruti, you are correct. Okay. Next question. If pth term of a sequence of an AP, if pth term of an AP is Q and qth term of an AP, qth term is P, then show that P plus qth term 0. If pth term of an AP is Q and qth term is P, then show that P plus qth term is 0. Okay, to find the specific term of an AP, what we need? We need the first term of the AP and common difference of the AP. Here, first term is not given and common difference is also not given directly, but indirectly, first term and common difference are given. That means if pth term is given and qth term is given, let us assume let A be the first term and D be the common difference of the AP. Let A be the first term and D be the common difference of the AP. So TP is equal to Q. TP means pth term. This implies, what is the formula for nth term? Tn is equal to A plus n minus 1 into D. So TP is equal to A plus P minus 1 into D is equal to Q. Let us consider this one as equation 1. Again, it is given that TQ is equal to P. This implies A plus Q minus 1 into D is equal to P. Let it be equation 2. Guys, quickly note it down. We'll go to the next page. Done, complete. Should we move? So Tp is equal to Q implies A plus P minus 1 into Q, P minus 1 into D is equal to Q. TQ is equal to P implies A plus Q minus 1 into D is equal to P. This is equation 1 and this is equation 2. Right? Equation 1 minus equation 2. So A plus P minus 1 into D minus A minus Q minus 1 into D equals to Q minus P. So plus A minus A cancels. From these two terms, P minus 1 into D minus Q minus 1 into D, we can take D as common. So P minus 1 minus Q minus 1 into D is equal to Q minus P. So this implies P minus 1 minus Q plus 1 into D equals to Q minus P. This in plus 1 minus 1 cancels. P minus Q into D is equal to Q minus P. This implies D equals to Q minus P upon P minus Q, which is equal to minus 1. Okay. So common difference of the P is minus 1. Next is to find out the first term. Okay. If we can substitute the value of D in any one of the two equations, either equation 1 or equation 2, we can get the value of A. Write down substituting value of D in equation 1. Substituting value of D in equation 1, A plus P minus 1 into minus 1 is equal to Q. So A is equal to Q plus P minus 1 or PQ minus 1. Clear? Now we have to find out the TP plus Q. TP plus Q is equal to A plus P plus Q minus 1 into D. Tn is equal to A plus N minus 1 into D. Tn is equal to A plus N minus 1 into D. What is A? A is equal to P plus Q minus 1. So this is equal to P plus Q minus 1 plus P plus Q minus 1 into D. What is D? D is equal to minus 1. So this is equal to P plus Q minus 1 minus P plus Q minus 1, which is equal to 0. Is it clear to you? Write in the chat box. Is it clear? Okay. Then come to the next question. The next question is, if A1, A2, A3 up to An if A1, A2, A3 up to N are in a P, then show that one upon root A1 plus root A2 plus of 1 upon root A2 plus root A3 plus 1 upon root A3 plus root A4 plus up to 1 upon root N plus root N minus 1 equal to N minus 1 upon root A1 plus root N. Okay. This is the question. If A1, A2, A3 up to N are in a P, then show that 1 upon root A1 plus root A2 plus 1 upon root A2 plus root A3 plus up to 1 upon root N plus root N minus 1 is equal to N minus 1 upon root A1 plus root N. Okay, come to the proof. A1, A2, A3 up to An minus 1 are in FP. This implies A2 minus A1 equals A3 minus A2 equals A4 minus A3 equals An minus An minus 1 is the common difference D. Okay. So LHS of the expression is 1 upon root A1 plus root A2 plus 1 upon root A2 plus root A3 Now rationalize the irrational terms and multiplying the conjugate factor. So we can write this is equal to root A2 plus root A1 into root A2 minus root A1 plus root A3 minus root A2 upon root A3 plus root A2 into root A3 minus root A2. Root An minus root An minus 1 upon root N plus root N minus 1 into root N minus root N minus 1. Okay. This is equal to A plus B into A minus B square minus B square. A2 minus A1 plus root A4 minus root A3 upon A4 minus A3 A2 minus A1 is D, A3 minus A2 is D, A4 minus A3 is D, and An minus An minus 1 is D. LCM of the expression will be D. plus root a2 minus root a2 plus root a3 minus root a3. Root n minus root a1 by t. Again rationalize. D into so a minus b into a plus b will be a square minus b square. An is the nth term and a1 is the first term, d is the common difference. So an is equal to a1 plus n minus 1 into d. D cancels. Okay. I hope it is clear to you. Hello. Write in the chat box. Is it clear? Mm. Then next question. Sum of n terms of an FP. Next question is if ABC be the pth, qth and rth term of an FP, then show that A into Q minus R plus B into P minus Q plus C into r minus p is equal to 0. Okay, this is the question. Try to prove it. If ABC be the pth, qth, and rth term on a P, then show that A into Q minus R plus B into R minus P plus C into P minus Q is equal to 0. Let's come to the solution. Let A be the first term and D be the common difference of the FP. Let A be the first term and D be the common difference of the FP. So pth term tip P is equal to A plus P minus 1. So ABs are used. So consider let alpha be the first term and D be the common difference. So tip P is equal to alpha plus P minus 1 into D, which is equal to A, and TQ is equal to alpha plus Q minus 1 into D, which is equal to B, and TR, rth term, is equal to alpha plus R minus 1 into D, which is equal to C. Let it be equation 1. This is equation 2. This is equation 3. Okay. Now subtract equation 1 from equation 2. Equation 1. Equation 1 minus equation 2 will be this from this. So alpha minus alpha will be 0. So this term minus this term, we can take D as common. P minus 1 minus Q minus 1 will be P minus Q. So P minus Q into D will be A minus B. So P minus Q is equal to A minus B upon D. Similarly, if you subtract the third equation from the second equation, equation 2 minus equation 3, it will give you Q minus R is equal to B minus C by D, and third equation, subtract the first equation from the third equation, R minus P is equal to C minus A upon D. Okay. Now the value of A into Q minus R plus B into R minus P plus C into P minus Q. This is equal to A into Q minus R is B minus C upon D plus B into R minus P, C minus A upon D plus C into P minus Q, A minus B upon D. So LCM of the expression is LCM is D. So A into B minus C plus B into C minus A plus C into A minus B. This is equal to AB minus AC plus BC minus AB plus AC minus BC upon D. Plus AB minus AB cancels, plus BC minus BC cancels, plus AC minus AC cancels. 0 upon D is equal to 0. Okay. Is it clear to you? Hello? Is it clear? Write in the chat box. Then come to sum of n terms of an AP. Sum of n terms of an AP. Let A be the first term. Let A be the first term and D be the common difference. let A be the first term and D be the common difference of an FP, then the sum of n terms Sn is given by Sn is equal to n by 2 into 2a plus n minus 1 into d. This can be written as n by 2 into a plus n minus 1 into d. This is equal to n by 2 into first term plus last term this is equal to n by 2 into sum of the terms equidistant from beginning and end. Sum of the terms equidistant from beginning and end. Come for the explanation. A is the first term and D is the common difference. The sequence is given by P is given by A plus D, A plus 2D up to A plus n minus 1 into D. This is the sequence. The sum of n terms Sn is equal to A plus D plus A plus 2D plus A plus 3D plus up to A plus n minus 1 into D. Okay. Again, write in Sn in reverse. That means last term will be first term. A plus n minus 1 into D. A plus n minus 2 into D. A plus n minus 3 into D plus up to A. Now take the sum of the two series. Okay. So Sn plus Sn will be 2 times Sn. Now club the first term of first series with the first term of the second series. Add these two terms. Okay. A plus A, that is 2A plus n minus 1 into D plus, now add the second term of the first series and second term of the second series. A plus A will be 2A plus n minus 2 into D plus D. N minus 1 into D plus club the third term with the third term. A plus A 2A, n minus 3 into D plus 2D, n minus 1 into D. Similarly, add the last terms, 2A plus n minus 1 into D. So 2A plus n minus 1 into D, 2A plus n minus 1 into D, 2A plus n minus 1 into D up to 2A plus n minus 1 into D. How many terms are there? N terms. So this will be 2 times Sn is equal to n into 2A plus n minus 1 into D. 2 times Sn is equal to n into 2A plus n minus 1 into D. So Sn will be n by 2 into 2a plus n minus 1 into d. I hope it is clear to you. Let us discuss a couple of rudimentary questions, right? Find the sum of first 20 terms. Find the sum of first 20 terms of the sequence 3, 7, 11, 15. Okay, this is the question. $820. Trupti Women's Higher Secondary, Basudevpur. Is it Bhadrak Basudevpur? Hello? Okay, come to the solution. Okay. What was the sequence? The sequence was 3, 7, 11. 3, 7, 11, 15. Okay, here the first term A is equal to 3. Common difference D is equal to 7 minus 3, which is equal to 4. So Sn S20. Sn is equal to n by 2. Sn is equal to n by 2 whole into 2a plus n minus 1 into d. So S20 is equal to 20 by 2 into 2a, 2 into 3 plus n minus 1, 20 minus 1 into d is equal to 4. This is equal to 20 by 2 is 10. 2 3 is 6. 19 into 4. Okay. 10 into 6 plus 19, 4 is 6, 76. 76 plus 6 is 82. 10 into 82 is equal to 820 is the answer. Is it clear? So guys, today's session consists of two lectures, lecture 1 and lecture 2. Lecture 1 is from 7:30 to 9 and lecture 2 is from 9:15 to 10:45. So there is a 15 minutes gap. If you want to take the gap of a 15 minutes, is well and good. If you don't want, then I will continue the class. Please write in the chat box whether you want the gap of 15 minutes or you want to continue. If you want the break of 15 minutes, write in the chat box, we want the break. If you don't want the break, write in the chat box, let's continue. Your first session is over. Now the time is 9 a.m. First lecture is from 7:30 to 9. And there is a break of 15 minutes according to the DHC. Okay. 9:15 to 10:45. Quickly write down in the chat box whether you want to continue the class or you want to take the break. There is a break of 15 minutes. Hello. Comment on the chat box whether you want to take the break or want to continue the class. Abhinash, Vijay, GSS Fulbani, Government Women's Higher Secondary, Luriana, Malay, Pradhan, Ramji Higher Secondary, Shubhangin Das, Samya, Trupti Women's Higher Secondary, and Xiaomi. Write in the chat box, want to continue the class or want to take the break of 15 minutes? No response? कौन करिबा पिले तुमे ब्रेक नबा को चाहुछ 15 मिनिट ना क्लास कंटिन्यू करिया को चाहुछ तृप्ति वुमेन्स हायर सेकेंडरी राइट इन द चैट बॉक्स सौम्य शुभंगिनी राइट इन द चैट बॉक्स what happened guys why don't you respond you are not writing anything in the chat box you have to write whether you want to continue the class or want to take the break of 15 minutes okay okay we will start the class okay let's continue okay let's continue okay one continue okay continue so guys write down a question next question if S1 S2 S3 up to SP represent the sum of S1, S2, S3 up to SP represent the sum of n terms of p number of APs whose first terms are one, two, three up to p respectively, and common difference are 1, 3, 5 up to 2p minus 1, then find S1 plus S2 plus S3 plus up to SP. Let me explain you the question. S1 represent the first AP. S1 represent the sum of n terms of the first AP, whose first term is 1 and common difference is 1. S2 represent the sum of n terms of the second AP, whose first term is 2, common difference is 3. And S3 represent the sum of n terms of third AP, whose first term is 3 and common difference is 5, and so on. You have to find out the value of S1 plus S2 plus S3 up to SP. Okay, quickly answer this question. Come to the solution. S1 is the sum of n terms of the first AP, whose first term is 1 and common difference is 1. So S1 is equal to n by 2 into 2a. 2 into 1 plus n minus 1 into d is 1. Similarly, S2 is equal to n by 2 into 2a, 2 into 2 plus n minus 1 into 3. S3 is n by 2, 2 into 3 plus n minus 1 into 5, and SP is equal to n by 2, 2 into P plus n minus 1, and common difference is 2P minus 1. Okay. Thus S1 plus S2 plus S3 up to SP equals, so each of the expression contains n by 2, so hence we can take n by 2 as common, n by 2 times 2 into 1 plus 2 into 2 plus 2 into 3 plus 2 into P. So 2 times 1 plus 2 plus 3 up to P plus n minus 1 into 1, n minus 1 into 3, n minus 1 into 5, n minus 1 times 1 plus 3 plus 5 up to 2P minus 1. Right? So which is equal to n by 2 times 2 into 1 plus 2 plus 3 up to P is P into P plus 1 by 2 plus n minus 1. Sum of first natural numbers is P square. Right? 2 to cancels. So n by 2 into P square plus P plus np square minus P square. Okay. Plus P square minus P square cancels. So you can take P as common, np by 2 into 1 plus np. This is the answer. Is it clear? Did you understand, guys? Write in the chat box. Okay, let's move forward. Come to the properties of FP. Property 1. If a constant quantity the same constant quantity is added to each term of an FP, then the resulting sequence is an FP. If the same constant quantity is added to each term of an FP, then the resulting sequence is an FP. Come to the explanation. Let A1, A2, A3 up to AN be an FP. That means A2 minus A1 is equal to A3 minus A2 is equal to N minus N minus 1, or you may write it as A plus D, A plus 2D up to A plus N minus 1 into D. This one will be better. Now add same constant quantity K to each term of the sequence. It will be K plus A. Then second term will be K plus A plus D. Third term will be K plus A plus 2D. And the last term, that is the nth term, will be K plus A plus N minus 1 into D. Right? Now we have to check whether it is an AP or not. So the difference between these two terms is D. Difference between these two terms is D. And difference between the last term and last to last term is D. And the sequence is an AP. Okay. This is your property 1. Property 2 is the similar property 1. If same constant quantity is subtracted from if same constant quantity is subtracted from each term of an AP, then the resulting sequence is an AP. If same constant quantity is subtracted from each term of an AP, then the resulting sequence is an AP. Let us consider the AP A plus D, A plus 2D, up to A plus n minus 1 into D. Now subtract the same constant quantity K from each term. It will be A minus D, A plus D, sorry, A minus K. A plus D minus K, A plus 2D minus K, A plus n minus 1 into D minus K. So difference between the second term and first term is D. Difference between the third term and second term is D. And difference between the nth term and n minus 1 term is D. Hence the sequence is an AP. This is your property 2. Now come to property 3. If each term of an AP is multiplied by same constant quantity K, if each term of an AP is multiplied by same constant quantity K, then the resulting sequence is an AP. Then the resulting sequence is an AP. If each term of an AP is multiplied by same constant quantity K, then the resulting sequence is an AP. Okay, let's just consider the sequence as A plus D, A plus 2D, up to A plus n minus 1 into D. Now multiply each term of the sequence by same constant quantity K. It will be K. The first term will be K. Second term will be K plus K times D. Third term will be K plus K times 2D, 2KD. And the nth term will be A plus K times n minus 1D. Now check the whether the common difference exists. You see, second term minus first term. K plus KD minus K. That will be KD. Difference between the second term and the first term is KD. Difference between the third term and second term is also KD. Similarly, the difference between the fourth term and third term will be KD. So common difference maintains. Hence the sequence is an AP. This is your property 3. Now come to property 4. If each term of an AP is divided by, if each term of an AP is divided by same constant quantity K, then the resulting sequence if each term of an AP is divided by same constant quantity K, then the resulting sequence is an AP. If each term of an AP is divided by same constant quantity K, then the resulting sequence is an AP. Let the sequence be A plus D, A plus 2D, up to A plus N minus 1 into D. So now divide the sequence, each term of the sequence by some constant quantity K. It will be, first term will be K upon A, second term will be K upon A plus D upon K, third term will be A upon K plus 2D upon K, and the nth term will be A upon K plus N minus 1 into D upon K. So difference between second term and first term is D upon K, third term and second term is D upon K. So D upon K, hence the sequence is an AP. Okay, I hope it is clear to you. Right? Then come to the next property, property 5. If the terms of an AP are selected at a regular interval, if the terms of an AP are selected at a regular interval and forms a sequence then the sequence is also an AP. The terms of an AP are selected at a regular interval and forms a sequence, then the sequence is an AP. For example, let take the particular AP, let it be 2 or 5, 8, 11, 14, 17, 20. Okay. Now select the terms after one term. Let it be 5, then 11, then 17, then 23. Okay. So this is also an AP. Property 6. In an AP, sum of the terms equidistant in an AP, sum of the terms equidistant from beginning and end. In an AP, sum of the terms equidistant from beginning and end remains same. In an AP, sum of the terms equidistant from beginning and end remains same. That is, suppose the AP is A plus D, A plus 2D up to A plus n minus 3 into D, A plus n minus 2 into D, A plus n minus 1 into D. Right? First term, second term, third term, nth term, n minus 1th term, n minus 2 term. So first term from beginning, take the sum of first term from the beginning and first term from the end. First term from the beginning is end, and first term from the end is A plus n minus 1 into D, which is nothing equal to 2A plus n minus 1 into D, right? Sum of the second term from the beginning and second term from the end. A plus D plus A plus n minus 2 into D. This is equal to 2A plus n minus 1 into D. Third term from the beginning, that is A plus 2D, plus third term from the end, A plus n minus 3 into D, which is equal to 2A plus n minus 3, n minus 1 into D. Okay. So sum of the terms equidistant from the beginning and end remains same. Then come to property 7. The sum or difference of corresponding terms the sum or difference of corresponding terms of two APs always determines an AP. The sum or difference of corresponding terms of two APs always determines an AP. So consider two APs simultaneously. Let the first AP be A plus D1, A plus 2D1. Here the common difference is D1 up to A plus n minus 1 into D1. Now consider the second AP whose first term is B and common difference is D2. So the series will be B plus D2, B plus 2D2 up to B plus n minus 1 into D2. Okay, now take the sum of these two series. That will give you A plus B, A plus B plus D1 plus D2. Then the third term will be A plus B plus 2 times d1 plus d2, and the nth term of the sequence will be a plus b plus n minus 1 times d1 plus d2. Okay. Now check whether common difference exists or not. Difference between the second term and first term is d1 plus d2. Difference between third term and second term is d1 plus d2. So common difference exists and the sequence is an AP. Okay. Just a minute, please. Yeah. Okay, let us discuss the couple of good questions on arithmetic progression from JEE point of view. Okay. Read on the question. Question is first. So for arithmetic progression, theory part is over. Question number 1. If in an FP, five times the fifth term if in an AP 5 times the fifth term is equal to 8 times the eighth term. If in an AP 5 times the fifth term is equal to 8 times the eighth term, then find the sum of the first 20 terms. Then find the sum of first 20 terms of the AP. Okay, this is the question. If in an AP 5 times the fifth term is equal to 8 times the eighth term, then find the sum of first 20 terms of the AP. Okay. Come to the solution. If in an AP 5 times the fifth term, we have to find the sum of 20 terms. S20 is equal to 20 by 2. Let A be the first term and D be the common difference. 2A plus 20 minus 1 into D. This is equal to 20 by 2 is 10 plus 2A plus 19D. Okay. If we can get the value of A and D, we can calculate S20. Or if we can get the value of 2A plus 19D, also we can get the value of S20. So what is the given data? Given data is 5 times the fifth term. T5 times T5 is equal to 8 times T8. Right? So 5 times T5 A plus 5 minus 1D, A plus 4D is equal to 8 times A plus 7D. Okay. So 5A plus 20D is equal to 8A 56D. So taking all the terms into right hand sides, 8A minus 5A will be 3A plus 56D minus 20D will be 36D is equal to 0. Okay. This first 25 terms, it will be 25 by 2 plus 2A plus 24 into D. Okay, 25 by 2 plus 2A plus 24D. Okay. So A plus 12D is equal to 0. This implies 2A plus 24D, multiplying both sides by 2, 2A plus 24D is equal to 0. Hence S25 is equal to 25 by 2, 2A plus 24D is 0, which is equal to 0. Okay, then come to the next question. The number of terms of an AP is odd. the number of terms of an FP is odd, and the sum of odd terms is 245, and sum of odd terms. Odd term is first, third, fifth, like this. Is 248, and the sum of the even terms is 217. The last term exceeds the first term by 56. The last term exceeds the first term by 56. Then, which of the following is true? Option A, the number of terms is 17. Option B, the first term is 3. Option 3, the number of terms is 13. And option D, the first term is 1. Okay? Now try to solve. The number of terms of the episode come to the solution. Let us suppose the EP contains 2n plus 1 number of terms. N plus 1 number of terms. Suppose the EP contains 2n plus 1 number of terms. So, if a series contains odd number of terms, then the number of odd place terms is 1 more than the number of even place terms. So, number of odd place terms is equal to n plus 1. And number of even place terms is equal to n. So, for the odd place term, here odd place terms determines an AP and even place terms also determines an AP. So, A plus D, A plus 2D, A plus 3D, up to A plus n minus 1 into D. Sorry, 2n minus 1. 2n terms in 2n D. Odd place terms are A plus 2D, A plus 4D. These are odd place terms. Here the common difference is 2D. And even place terms are A plus D, A plus 3D. This is also an AP. This series contains n plus 1 terms. And this series contains n terms. Okay. Sum of odd place terms equals to 248. So n plus 1 by 2 into 2a, n plus 1 minus 1 nd is equal to 248. Okay. Again, sum of even place terms is equal to 212, 217. N by 2, the first term for the even place terms. So no, this is not A, this is A plus D, A plus 3D like this. A plus D, then 2 into A plus D. Plus n minus 1 into D is equal to 217. So this implies n by 2 into 2a, 2d plus nd minus d. Nd minus d plus 2d will be 2d. D is equal to 217. And difference between the first term and the last term. Difference between the first term and last term. Last term exceeds the first term by 56. Last term exceeds the first term by 56. What is the last term? A plus 2nd. A plus 2nd minus first term is A is equal to 56. So 2nd is equal to 56. So ND is equal to 28. Okay. Substitute the value of ND in equation 1 and also equation 2. So n plus 1 by 2 into 2A plus ND is 28 is equal to 248, and substitute the value of ND in equation 2 also. N by 2 into 2A plus 28 plus D is equal to 217. Okay. Now select which option is correct. UND is equal to 56. So n plus 1 by 2, 2A plus, oh, here it is, n plus 1 by 2A plus number of terms is odd place terms. Odd place terms, number of odd place terms is n plus 1. N plus 1 into D. A plus n plus 1 into D. A plus n plus 1 into D. Okay. So, mistake that out लिख odd place term n plus 1 by 2 into 2A plus n plus 1. Number of terms is n plus 1. So it is right, it is ND. The common difference is 2D. Okay, we have to write it again. Sorry guys. I'm using another page. The common difference 2D. Sum of all place terms equals number of all place terms is n plus 1, n plus 1 by 2 into 2a, n plus 1 minus 1, here the common difference is 2d, is equal to 248. Okay, so n plus 1 by 2 into 2a plus 2nd is equal to 248. Again, sum of even place terms. Sum of even place terms is equal to n by 2, 2 into a plus d. For the even place terms, a plus d is the first terms, plus n minus 1 into 2d is equal to 217. This implies n by 2 into 2a plus 2nd minus 2d plus 2d cancels, plus 2nd is equal to 217, right? Difference between the last term and first term. Last term minus first term, which is equal to 2nd. 2nd is equal to 56. Okay. This is equation 1. This is equation 2. Now substitute the value of 2nd in equation 1 as well as in equation 2. So n plus 1 by 2 into 2a plus 56 is equal to 248, and n by 2 into 2a plus 56 is equal to 217. Clear? So solving these equations, we can get the, so two unknown, a and n, and two equations. Solving these two equations, we will get the value of n and n. So n is equal to 7 and a is equal to 3. Clear? Then come to next question. If the sum of n terms of an FP P is 5n square plus 4n, then find the common difference of the AP. If the sum of n terms of an AP is 5n square plus 4n, then find the common difference of the AP. Okay, this is the question. Very easy question, try to solve it. Sum of n terms Sn is equal to 5n square plus 4n. If Sn is equal to 5n square plus 4n, then we have to find out Tn. Nth term, Tn is equal to Sn minus 1. Tn is equal to Sn minus, Tn is equal to Sn minus 1. So 5 into n minus 1 whole square plus 4 into n minus 1, sorry, 5n square plus 4n minus 5 into n minus 1 square minus 4 into n minus 1. This is equal to 5 into n square minus n minus 1 square plus 4 into n minus 1. So 5 into a square minus b square, a plus b into a minus b. That is 2n minus 1 plus 4 into 1. So 10n minus 5 plus 4, which is equal to 10n minus 1. So Tn is equal to 10n minus 1. Tn minus 1 will be 10 into n minus 1 minus 1. So common difference D is equal to nth term minus its preceding term, that is n minus 1th term. So 10n minus 10n plus 10 minus 1 plus 1. So this is equal to 10. So common difference of the series is 10. Is it clear? Quickly note it down. So guys, I have to make a call to DHC. Stay connected. Let's move to the next question. In an AP, sum of n terms in an AP sum of n terms is 700 and sixth term is 7 and sum of 7 terms is 7. Find nth term. Find nth term. This is the question, okay? Sn is equal to 700 n by 2 plus 2a plus n minus 1 into d is equal to 700. Sixth term is 7. Let it be equation 1. A plus 5d is equal to 7. Equation 2. Sum of 7 terms. 7 by 2 into 2a plus 6d is equal to 7. So 2a by 2, a plus 3d. A plus 3d is equal to 1. It is equation 3. If you substitute the equation 3 in equation 2, you will get the value of d. So a plus 3d minus, sorry, a plus 5d. A plus 5d minus a minus 3d is equal to 7 minus 1 is 6. So 2d is equal to 6. Implies d is equal to 3. If d is equal to 3, then what will be the value of a? A is equal to, a plus 3d is equal to 1. A plus 3d is equal to 1. A plus 9 is equal to 1. Implies a is equal to minus 8. Now substitute the value of a and d in equation 1. We'll get the value of n. So n by 2 into 2a. 2a is minus 16 plus n minus 1 into d. d is 3 is equal to 700. So minus 16n plus 3n minus 3 is equal to 1400. Okay. So minus 16n plus 3n. N will be negative. How come? Is it not possible? A is equal to minus 8, D is equal to 3. N by 2 into 2a plus n minus 1 into D. D is 3. Minus 16n, sorry. Minus 16n plus 3n square minus 3n is equal to 1400. So 3n square minus 19n is equal to 1400. So 3n square minus 19n minus 1400 is equal to 0. Okay. N square minus 14n minus 19n minus 14n is equal to 0. Then what will be the value of n? So n is equal to, so now factorize it, 3n plus 56 into n minus 25 is equal to 0. So n is equal to minus 56 by 3, which is impossible. N is equal to 25. We have to find Tn, that is T25. T25 is equal to A plus A is minus 8. N minus 124 into D is 3. So minus 8 plus 72, which is equal to 64. This is the answer. Okay. So guys, your today's session is over. Rest of the thing will be discussed in the next session.